Good afternoon, TechNation. Thank you all for participating in today's Webinar Wednesday. We have a fantastic turnout for today's presentation with over 800 attendees registered. A few notes before we begin. Earlier today, you were emailed a Webinar Wednesday workbook. If you did not receive a copy, you can download one right now by visiting imtechnation.com/webinars and clicking on today's presentation. During today's webinar, all lines will be muted, but you can submit questions during the presentation by using the questions feature on the dashboard on the right-hand side of the screen. If you are having difficulty, please email us at webinar@ndpublishing.com. Today's webinar is eligible for 0.1 CE credits from the ICC. To obtain your certificate of attendance, you must complete the post-webinar survey at the conclusion of today's presentation. This survey will appear immediately on your computer screen after the presentation is complete. Certificates will be emailed on or before March 19th. TechNation would like to thank today's sponsor, Fluke Biomedical. Fluke Biomedical leads the world in the design and manufacture of biomedical test and diagnostic imaging equipment. Please visit flukebiomedical.com to learn more. Our presenter today is Dana Ingram, Product Manager for Fluke Biomedical. Dana manages the Defibrillator, AED, and Pacemaker analyzers and testers product line. She has over 7 years of product marketing experience, as she was previously a product manager for the Global Strategy and Development Infusion device group at CareFusion, and prior to that, she held several product marketing positions within Mentor Worldwide, a Johnson & Johnson company. Dana, we look forward to your presentation today, Defibrillator and AED Best Practices, Saving Lives One Test at a Time. Dana, you may begin whenever you are ready.
Great, thank you. Well, welcome everyone to Fluke Biomedical's educational webinar. Today we'll be discussing defibrillator and AED testing best practices to ensure proper performance of modern defibrillators and AEDs. So let's go over a few things that we will be covering in today's session. 1, why is defibrillator and AED testing important? 2, we will review global testing standards for both defibrillators and AEDs, and then we will go over best practices for testing your AEDs and defibrillators. So let's start off with what do defibrillators and AEDs do? Well, it goes without saying that defibrillators are life-saving devices. An electronic defibrillator and an AED's main job is to convert abnormal heart arrhythmias to normal and convert VFib back to normal in the patient. In most cases, you only have a few moments to do this. And in fact, every minute that passes where a patient is not receiving defibrillation, the chance of survival is reduced approximately 10%. So I think we can all agree that it's vital for defibrillators and AEDs to be ready to use the first time, every time. To ensure this, hospitals are required to determine their own testing protocols and frequencies based on a few things, usually based on manufacturer recommendations, prior equipment testing, and of course failure history of the device. So why is defibrillator testing important? Well, it saves lives. It's really as simple as that. Every year, more than 300,000 Americans of all ages die from sudden cardiac death. However, a person's odds of survival increases tenfold if there is an electronic defibrillator around, and that includes AEDs as well. According to the American Heart Association, up to 100,000 American lives could be saved annually if defibrillators and AEDs were more widely available. Now just imagine that survival rate on a global scale. It's important that we in the biomedical community make sure that defibrillators and AEDs work the first time, every time. These medical devices are highly regulated by the FDA and other global governing bodies. But more importantly, if we do not have a fully functioning device, the life of the cardiac arrest patient is at severe risk. So now that we've discussed why defibrillator and AED testing is important, let's discuss some of the regulatory standards for testing. Back in March 2013, about 2 years ago, the FDA proposed an order aimed at helping manufacturers improve the quality and reliability of AEDs, also known as automated external defibrillators. The proposed order would require manufacturers to submit pre-market approval, also known as PMA, applications just like they do with defibrillators today. On January 28th of this year, the FDA announced that they will require makers of AEDs to submit more data after years of recalls and manufacturing issues and problems. Now, this is an aim from the FDA to improve the quality and reliability of these devices, much like they do with defibrillators today. Per the FDA, the Food and Drug Administration will require AED manufacturers to submit pre-market approval applications which undergo a more rigorous review than what was required to market these devices in the past. The review will focus on more of the critical requirements needed to ensure the safety and reliability of AEDs and their necessary accessories, which include the batteries, the pads, any adapters, and hardware keys for pediatric use. So again, the FDA is already requiring this for defibrillators, but they're becoming more rigorous with AEDs. Additionally, by requiring the pre-market approval for these devices, the FDA will receive information about an AED's manufacturer quality systems. The FDA will also conduct inspections at manufacturer facilities prior to this approval. And then after approval, the manufacturers will be required to submit to the FDA any changes made to the devices that affect safety or the effectiveness and annual reports on the device performance. Now, they're already doing this for the defibrillators, and now they're doing this for the AEDs. And a couple important dates to know is that the FDA does not intend to enforce the PMA requirement for AEDs until July 29th of 2016. So about a year and a half from now. And as long as the manufacturers notify the FDA of their intent to file for PMA by April 29th. So as long as you notify the FDA by April 29th of this year, it's a month and a half, the enforcement won't go into effect until July 29th of 2016. The FDA also does not intend to enforce the PMA requirement for currently marketed devices, which include necessary AED accessories, until January 29, 2020. So there's still time, but it's important to note that the FDA is enforcing more rigorous regulations and standards, and so it's important to start becoming more serious and diligent about preventative maintenance testing, not only on your defibrillators, but also now on your AEDs. So let's review some of the testing standards for just defibrillators. IEC standards establishes particular basic safety and essential performance requirements for cardiac defibrillators. Most, if not all, manufacturers follow these IEC standards. You can view which standards the product adheres to by looking in one of three places. The device under test user manual. Now, this user manual will come with the device upon purchase, and usually the IEC standards will be listed either in the beginning of the manual or the back at the end. You can also review this in the service manual. Again, they should be listed in the beginning or at the end of the service manual. And then another place to look is the Declaration of Conformity. Now, IEC is the global gold standard, and here in the U.S., ANSI/AAMI duplicates those standards. So when you hear me say IEC, ANSI/AAMI, they're really interchangeable. They go off the same gold standards. So who should follow these standards? Well, hospital, biomeds, and ISOs should always follow these standards because they are testing medical devices that are highly regulated, as well as manufacturer specifications and recommended inspection procedure and test equipment. So manufacturers are also adhering to these standards. And then the Joint Commission, which hospitals adherence to formal safety programs. So we've discussed some of the reasons to test from a variety of different regulated entities such as the FDA and IEC. And just to really point out, the FDA's main focus is to really regulate the medical device manufacturing, sale, and ongoing safety review within a country. It also approves defibrillator designs that can be sold in the U.S. or a specific country based on data collected using products like the Impulse 7000 or other defibrillator analyzers when following the prescribed tests in the IEC or local national standards for defibrillators, pacemakers, and monitors. And the IEC and CAME standards really specify what must be tested and how it should be tested when evaluating the safety and effectiveness of these medical device designs. And it's also important to note, you really want to make sure that you're reviewing the manufacturer's specifications. Manufacturers recommend what should be tested for their individual products and how often testing should be done. Defibrillator testing is recommended at least 2 times a year, but again, please look in the service manual, the user manual, and you will see what the manufacturer's specifications are for your particular device. As well as the Joint Commission. Now, the Joint Commission is USA-based only, and this accredits hospitals, including biomed departments. Medical device testing accreditation is based on the hospital's medical device test management plan. And testing is to be based on the manufacturer's recommendations. And the only time it won't be is unless other objective evidence shows alternative testing is more effective. So let's take a break. I just want to take a quick poll and see how many times do you currently test your defibrillators annually. And this could be once a year, twice a year, maybe more, or maybe you don't test at all. And we just want to kind of gauge and see where you are with your PM testing in your area.
Hey Dana, this is Jamie. I have launched the poll, so right now the attendees are answering the question, how many times do you currently test your defibrillators annually? Once, twice, 3 or more times, or do you not currently test? While everyone is still busy answering, I will remind you, we do accept questions throughout the presentation. You can use the questions feature on the dashboard on your right-hand side. We will hold all questions to the end of the presentation when we'll have a formal Q&A session. Dana, right now 76% of the audience has voted. And it looks like our clear winner is twice a year.
Wow, that's great to know because that is absolutely what is recommended both by us at Fluke Biomedical and by most manufacturers and standards out there today. So that is great to know. Well, let's move on and discuss what are some of the best practices for defibrillators. Now that we kind of have gauged an understanding of where you are with your test procedures and the regulatory reasons behind testing. So today's more sophisticated defibrillators not only deliver the specified power selected by the user, but also determine the patient's specific input impedance and delivers that specified power based on each individual patient's impedance. Everybody's human impedance level is different and it really varies from person to person. However, the middle ground is about 50 ohms and is what most devices are tested at today. And it's always important to review and follow the manufacturer's recommended test procedure. However, it's also crucial to test more than just 50 ohms to account for all human impedance levels. Now, although 50 ohm load testing is the standard and what you will see in most user manuals, human impedance levels can range from 25 to 180 ohms. And as mentioned, everybody's human impedance levels varies, and you won't be able to tell what somebody's human impedance level is by just looking at him or her. Today's defibrillators are also likely to have more than just ECG and arrhythmia parameters and functionality, which include more than just 3, 5, or 10 lead wire connections to the patient. Now, each parameter will be used in diagnosing the patient's condition and therefore must function properly and be checked. So other test parameters of a patient to test and check are, of course, the ECG, the arrhythmia, the shock advisory functionality, if any SpO2 is present, if NIBP, which is non-invasive blood pressure, or IBP, invasive blood pressure, is present, and even perhaps EtCO2. It is also important to test external transcutaneous pacemaker functionality because it's integrated into most defibrillators. So that reason alone, we should test for it. For directions on how to test and when to test, please refer to the manufacturer's recommendations. And if those aren't available, review the standards, which are either the IEC or AED standards. Now, another test function to perform is electrical safety. An electrical safety test should be performed on all products that uses electricity, which includes medical devices such as defibrillators. Reasons for testing electrical safety does not change based on the medical device. It's always required and important. It's especially important that these tests are completed when patients are made more vulnerable when placed with sensor-type devices such as pacemakers. Again, always review the manufacturer's recommendations and international standards. And another important function to test is communication, especially for emergency medical services like paramedics. This may require more test tools than just a defibrillator analyzer. It may require pressure meters, IVP simulators. It may require communication transceivers or testers. You just really want to make sure that every function of the device under test is being tested and works properly. So let's change pace a little bit. Now that we understand what defibrillators are and why it's important to test them, I wanted to just briefly discuss what is actually being tested on a patient. So it's important to remember that it's the current that flows through the myocardial tissue that defibrillates, even though the defibrillator settings are calibrated in joules, which are units of work, and non-amperes, the typical unit of measure. Current is affected by the variety of impedances presented by different tissues it must pass through before reaching the heart. And each tissue type, which could be skin, fat, muscle, bone, etc., all of these have a different impedance. And skin impedance can really vary depending on whether the skin is either dry or damp. And current is also affected by the impedance of the defibrillator itself, which includes the paddles and the pads. Impedance is the natural dynamic resistance to the defibrillation or other inductive electrical occurrences applied to the body by an outside appliance or force. So essentially, to simplify it, it's the body's resistance to current flow. Now, some people, as we mentioned before, have naturally higher impedances than others. Human impedance variability has been shown to vary from either 25 ohms to 180 ohms. And again, you can't tell if someone has a high or low impedance by simply looking at him or her. That's why it's really necessary to test all different ohm levels on a defibrillator, not just the standard 50 ohms. Here at Fluke Biomedical, the 7010 defibrillator flexible load box can help you test different levels. Now, the 7010 load box replicates all patient thoracic impedance loads from anywhere from infants to overweight adults. It also simulates user-selectable impedances as high as 200 ohms accurately, so it's able to go up to that 180 ohms needed. And again, it also meets all defibrillator quality testing standards, which is very important in today's rigorous testing needs from the FDA. So you might be thinking, well, then what are the recommendations? If we have a standard 50 ohms and then we have recommendations, where do I go from here? Well, if you look at the IEC 60601 2-4 standards and then similar sections at AMI ANSI, the standard requires the use of test load impedance of 25, 50, 75, 100, 125, 150, and 175 ohms at each energy setting to ensure proper current is delivered to the patient with different impedance levels. However, you will see in most user manuals or manufacturing guidelines that call out just 50 ohm load testing. But I think we have identified why it's important to test at different load resistance. So then when should you be testing with these other loads? When would it be required to test more than just a 50 ohm load? Well, best practice is to perform a thorough inspection, including the test loads required by the standards on the initial incoming inspection or also called acceptance testing. And then anytime the defibrillator battery, capacitors, charging time, or impedance circuits have been repaired, you want to, again, do those tests. The extra test loads can also be very helpful in troubleshooting clinical complaints of defibrillators' apparent failure to deliver adequate energy to treat a patient. So let's move on to AEDs. Now that we've discussed testing practices for defibrillators and its importance, let's move on to AEDs. The use of AEDs has really been growing over the years. And as you can see, we've kind of presented an analogy of fire extinguishers or fire hoses for AEDs. So what is an AED? Is it a fire extinguisher or a fire hose? I want you to think of fire extinguishers as first responders. Some of you may even have a fire extinguisher in your house in case of emergency. It could be located in your kitchen, your living room, utility closet, somewhere that's really accessible in case you need it very quickly. They can be used almost anywhere with little to no training, just like AEDs. So AEDs are fire extinguishers relative to cardiac arrest. And AEDs really require less clinical training to use and are intended for that crucial first 3 to 5 minutes of cardiac arrest when life might be saved with lower energy settings. However, the AED's effectiveness is determined by much more than simply just having the device around. A complete program that includes risk assessment, training, maintenance, and record keeping must be in place, much like defibrillators. To enable AEDs to be used by just anyone, AEDs contain very sophisticated computer assessments of the patient's ECG and determine shockable versus non-shockable ECG wave patterns with the patient. AEDs are battery powered, so they really can be completely portable and brought to the victim wherever he or she may be. The AED batteries are crucial to the delivery of the right amount of current flow to convert cardiac arrest into normal sinus ECG. So why is it important to test AEDs? Well, high failure rates have attracted increased FDA scrutiny, additional audits of defibrillator manufacturers, and other actions including voluntary corrective actions and recalls, which is why you're seeing more rigorous rules and guidelines coming down from the FDA today. According to the Food and Drug Administration, from January 2005 through September 2014, the FDA received approximately 72,000 medical device reports associated with the failure of these devices. Now, since 2005, manufacturers have conducted 111 recalls affecting more than 2 million AEDs. The problems associated with many of these recalls and reports included design and manufacturing issues, such as inadequate control of components purchased from other suppliers. And some of those root causes of these failures have been microchip failure, also battery failure, and power supply and recharging circuit failure, to name a few. And a lot of these failures reported could have been solved by performing preventative maintenance tests. And hopefully a lot more will be solved now with the new FDA regulations. And while one might assume that AEDs are just hands-off devices and should only be touched when needed to treat a cardiac arrest, in reality, AEDs require attention to ensure that defibrillation therapy, that shock therapy, will be delivered when needed. So you could do a few different tests. We have some daily check tests, monthly, and then more detailed tests. Let's start off with the daily. So a daily check really just includes, a visual check, looking at the device, making sure there's no cracks, it doesn't look broken, it looks like it's in good health and in good shape. And then, of course, a supply inventory. Does it have the correct pads in place? Are there extra batteries? Making sure that that AED has everything it possibly needs to be used when needed. And this can be done by anyone from a clinical staff unit to a biomed. Now, monthly tests include checking the battery. So replace the AED battery, doing a battery insertion test, and replace any used supplies. It's vital that we make sure that that battery is is functioning and has the right amount of energy with it. And then any used supplies. So if you see that pads have already been reused, discard those and present new pads with the AED. And then detailed checks. Those include ECG analyst results, as well as the voice or audible prompts that still function. So it's really important that you test those voice audible prompts to make sure that you can clearly hear the instructions coming out of the device. Instructions on testing should be provided in the user manual, manufacturer recommendations, or the IEC and the ANSI standards. So I know we did a quick poll to see how many of you were testing your defibrillators, and we'd like to do that again, but with AEDs. How many of you are currently testing your AEDs annually? Is it once a year, twice a year, or maybe you don't test at all?
Hi, Dana. This is Jamie again. Right now, attendees are able to answer the question, how many times do you currently test your AEDs annually? Again, the options for answers are once a year, twice a year, 3 or more times a year, or do not currently test. While we're waiting for the audience to answer, I will remind you of our post-webinar survey today. It will appear immediately following today's webinar. You do need to answer all questions in the post-webinar survey to receive your certificate of attendance, which will help you with your .1 credits from the ICC. Dana, right now we have 78% of the audience has voted. There is a close tie between answers. 35% says once a year, and 42% answered twice a year.
Wow, that's great. That is great to know. So as we discussed, you're already keeping up with the FDA regulations that they're putting in place, and already halfway there. So that is really great to know. You're one step closer to really saving a patient's life. So really the purpose of this webinar has been to give you a high-level overview and inform and remind you of the changes in regulations and standards and in technology and the failure rate of that technology at a high level, and the types of testing and test instrumentation you may need to consider for using defibrillator and AED quality assurance and performance testing. Here at Fluke Biomedical, we wish to help you reach the best decisions and provide you with the appropriate test tools to do the work that you really need to get done. So with that, I want to thank you for listening to me for these past 30-plus minutes, and I want to kind of hand over the stage to you and allow you to ask any questions that you may have.
Hi, Dana. Bethany here. That was awesome. We have quite a few questions, so if you don't mind, I'm just going to start with the very first one. Let's see. How often should you calibrate the time defibrillator?
Great question. So the manufacturer of the particular make or model of that defibrillator really determines the inspection frequency, including calibration. Here in the U.S., calibration means the act of adjusting the device to meet its manufacturer specifications. So you will find that defibrillators need to be inspected or calibrated about twice a year. Certainly they must be checked twice per year whether or not adjustments need to be made. Hopefully that helps.
The next question is, what is the way to check AED that uses only adhesive pads?
So we'll take that one kind of on the fly. This is Jerry Zion, the Global Training Manager. What you need to do is modify a set of pads so that they, instead of ending up in the adhesive pad, they end up in a banana jack, banana plug that you can plug into a banana test lead opening. And that's exactly how we do it at Fluke Biomedical. There are some adapters that we have that are already prepared for some models of defibrillator and the pads that they use and the specific connection to the junction cable. That's the easiest and quickest way to do it. You only waste one pad and you have a test lead set up that you can use over and over again.
Great. Okay. Here's another question for you. What does one do if the external temporary pacemaker they need to test is a transvenous pacemaker? Can this be tested using the Impulse 7000?
Well, external transvenous pacemakers are typically not incorporated into defibrillators, and the Impulse 7000 is therefore not really intended to be used to test them. We recommend using the SigmaPace 1000 pacemaker analyzer to test either temporary external transcutaneous or temporary external transvenous pacemakers.
Wonderful. Okay, another question came in. What should one do if the defibrillator's pacemaker brand is not listed in the Taser load selection list of the Impulse 7000?
That's a great question. So what you want to do is you want to use the other selection, and by using the other selection with the internal 50 ohm load of the Impulse 7000, that will help properly test your defibrillator.
Fantastic. Okay, the Impulse 3000 and the Impulse 40,000 were the prior Fluke Biomedical defibrillator analyzers used. These had automated test sequences built in, which were also used. How can Impulse 7000 be used in the same way?
Well, while it is true that Impulse 7000 does not include any automated test sequences built in, it is capable with the Answer Test Automation software suite from Fluke Biomedical. So in the Answer Test library, there are equivalent automated test sequences built into several example test templates. And this can be incorporated as a standard way of testing defibrillators, or they can be customized to be defibrillator make model specific and then saved with defibrillator make model specific file names for use during future testing to make it easier.
Fantastic. How can one tell the difference between an Impulse 6000 and an Impulse 7000?
So the Impulse 7000 includes the Pacer connection post and Pacer test selections. The Impulse 6000 does not. As well as the Impulse 7000 can be used with the 7010 external load accessory box, which allows you to test more impedance levels. And the 7010 load box is not compatible with 6000, only Impulse 7000.
Great. Okay, another question for you. Do you recommend discharging an AED when conducting the annual inspection?
Yes. However, some AED batteries are not rechargeable after they've been used, and so you have to be careful. Our recommendation, and in fact, the recommendation of the community of biomedical engineers that we have sampled, indicates that the biomed department should get a spare or two of the AED batteries for each model and make of AED that they have in the inventory, and have that to be used when you're doing the testing. I know it seems like that doesn't do an actual righteous test on that AED the way it sits and waits for its next use. However, it does preserve the AED battery for clinical use and nothing else.
Great. Okay, another one. What is the recommended impedance to be used when testing infant or pediatric type AED or defibrillators?
As far as I know, all defibrillator testing is done with a 50 ohm battery or 50 ohm load built into every single defibrillator analyzer that's on the market today. However, if there's any doubt, always check with the manufacturer's inspection procedure, because if a different impedance is required, it will be called out there. And then, of course, we're prepared because you can use the 7010 external load box with the Impulse 7000 to carry out that testing.
Very good. Okay, another question for you. The manufacturer of the defibrillator recommends an inspection once per year. You mentioned that defibrillators should be tested twice per year. How often should defibrillators be inspected?
Well, I'll refer you to a soon-to-be-available course or curriculum, entire curriculum that we have, but one course in particular within that curriculum, and that would be the defibrillator testing course. And what that curriculum is, it's about medical device quality assurance. We teach a method by which you use a risk-based assessment of any medical device, including defibrillators, and a series of criteria and answers to the questions to those criteria to determine the most appropriate frequency of inspection. In every case that we have tested this method on, you end up coming up with the same inspection frequency as the manufacturer will. So no matter what the standard says, mostly the manufacturer will agree. In this case, this manufacturer is kind of way out in left field somewhere because all other manufacturers of defibrillators will recommend twice per year. And the AED manufacturers will soon come to toe that line because they'll have to.
And it's also important to note that AED and defibrillator manufacturers may have different guidance in when to test your defibrillator AEDs. And it also could be, if it was an old defibrillator for an old user manual, it may not have the updated current FDA and IEC standards. So it just really depends the make, the model, and the year, because every year regulations have been changing. So a device maybe 5 to 10 years ago was only recommended for a year, but most currently we're starting to see 2-year recommendation, 2 times per year.
Excellent. Okay, here's another question for you guys. Can the test load shown in the picture be used along with an Impulse 7000 during test?
I'm sorry, state the question again, please.
Certainly. Can the test load shown in pictures be used along with an Impulse 7000 during test?
Indeed, yes. In fact, it can't be used by itself. It really needs to be used. We're talking about the 7010 external load accessory, and it needs to be used with the Impulse 7000 every time. It simply replaces the 50 ohm load that's built into the Impulse 7000 with the selectable loads in the box.
Wonderful. Approximately how many shocks should you get out of an AED?
Oh, that's a good question. It's going to vary with the make and model, and it's going to have guidance and guidelines that come from the American Heart Association and other clinical sources that have done great clinical studies on that. You certainly need to get at least 3 full energy shocks out of it, but generally you can get some more. But please look at the operating instructions of that AED and its specifications, because that's where you'll find that answer. And assume that it's going to vary until we prove it differently. But I would just say, look at the spec for the AED.
Okay, great. Here's another question for you. What Fluke analyzer do you recommend?
For our defibrillator analyzer, we really recommend the Impulse 7000, and we recommend also using the 7010 load box, as you will be able to test different impedance levels ranging from 25 to 180 ohms. So really together, the Impulse 7000 and the 7010 really make a complete system for preventative maintenance testing.
Okay, here's another question for you. What's the most common problems with a defibrillator?
That's another really great question, and I think the answer to that question will vary some. If you look at the databases, the CMMS or computerized maintenance management systems across the biomedical and engineering community, you can always assume that the things that are out in people's hands and connections that are made externally are going to fail first. So that includes trunk cables, ECG lead wires, any oximeter sensor cable, all of those cables and patient connections, including the defibrillator cable and paddles, or the trunk cable that goes to the disposable defibrillator pads. and that would include the same thing for AEDs. For AEDs, it's simpler because you only really have the trunk cable and then the disposable pads connections, and that's really about all. But those would be the things that are most likely to fail first, and then after that, we still rate batteries the next most probable thing to fail. So you really need to pay attention to battery maintenance and really good battery care to get the most life out of those batteries. So swapping them, making sure that they're completely charged up. We don't have time to go into that litany right now in this session. That would be a really great discussion just all by itself. And we had that discussion in our local Biomedical Association meeting where we were presented, there was a presentation by a local but very well schooled battery manufacturer for replacement batteries. So I think that's a really great question to touch some other time.
Fair enough. Here's another question for you. Are you saying that AEDs should be tested 2 times, or are you only recommending 2 times?
Well, all we can do is recommend. What we're saying is go look at the manufacturer's recommended inspection procedure, but also look at that with the understanding now that FDA is tightening the screws. They are making the requirements stricter. And as a result, your requirements should also become stricter. You'll never go wrong testing more frequently than the manufacturer says you just brutally have to. Everybody right now that is following best practices in testing, including testing AEDs, is doing it twice a year.
Absolutely, Jerry. At a minimum, it should be once a year, but we do recommend twice a year. As we have discussed, we have seen issues with the battery failure, power supply failure. You really want to make sure that those are working properly, and also keeping up to date with the new regulations coming down from the FDA. But again, always look at your user manual or service manual to see what the manufacturer recommends.
The other way to look at this, because I really want you to really think about this and not just follow just because everybody else is doing something. Our job as biomedical engineers is to reduce the risk to the patient from the use of the medical device upon them. And we see that with 72,000 incidents just about AEDs, just in the United States, that we absolutely are not inspecting either frequently enough or not looking at the right things in order to knock that the number of events and incidents down. So look at the number of incidents and problems that you're having today and start doing your AED testing twice a year and see how it affects the failure rate. It should pull the failure rate down. You should be finding things sooner when they're easier to fix, or fixing things before they fail because of the discoveries you're making, so that they really start falling more in a normal range. Because 72,000 incidents is not a normal range by anybody's measure.
Excellent. And I think you just touched on this, but just to clarify, did you say that there is an FDA interval requirement for testing AEDs?
No. FDA will not tell you an interval, nor will the standards tell you an interval. The interval comes from the manufacturer's recommended inspection procedure in the service manual of the make and model of defibrillator or any other medical device. We have this methodology that we use to assess using a risk-based assessment that typically comes up with the same frequency of inspection as a cross-check, especially because there are certain medical devices in certain parts of the world where the manufacturer doesn't give you a recommendation, so you really have to do a good job. So you can learn that from us by, as I said, following or taking that curriculum once we offer it. It'll be this year. So keep watching our new training that we make available.
Fantastic. Another question just came in. My tester is a standard 50 OHM. How do I test other loads?
You cannot. You need other loads in order to perform the testing on those impedance sensing circuits. It cannot be done with just one load. So you really need to rethink the capability of the test equipment that you have in your hands right now.
Great. Here's another question for you guys. What about Taser testing on defibs? Should the patient impedance vary in testing or just the standard 50 OHM internal load on an impulse?
Well, in fact, the Impulse 7000 has more than just a 50 ohm load for pacemaker testing. It certainly has a 50 ohm load, but it also has other values depending on the brand of pacemaker that's built into the defibrillator. So what we have always said is follow the brand setting, and you're able to do that. You've been able to do that on all of our legacy pacemaker testers, and you'll get the right load. When you can't, when we don't know or haven't gotten guidance from the manufacturer of a particular pacemaker, if it's not in the list, we use other, and that just picks the 50 ohm load. It may not be precisely the right load, but it will give us a performance outcome, a result that we can track over time and see if it's changing higher or lower. We can at least look at that trend of change. The other place to always look, as I said before, is the manufacturer's service manual for that pacemaker, if you can get it. Now, there may be some circumstances where it's simply totally not available.
Excellent. What software is needed to make the 7000 automated?
For the software we have for the 7000, we use our Answer automated software. Answer not only comes with defibrillator products, but also with our other test equipment. So we have a Answer suite for all of our analyzers, including the Impulse 7000.
Now, just to clarify, there is a part number that you can order that gives you a license for the Answer software for one computer, and you can buy along with your Impulse 7000. And that has been a very, very popular way to get at least one Answer license for one computer over the last 3 or 4 years. So you can buy Answer licenses for whatever plugins that you need for the various of our test instruments, but buying it in this little bundle along with the analyzer is a really good way to get it for at least one computer.
Absolutely, Jerry.
Great. Here's another one. Is it necessary to test energy output of AED devices similar to regular defib units?
Well, there's only going to be one, and that's because an AED always outputs its maximum, or if it doesn't, it's going to be controlled by the algorithm inside, not by switch selection. So you always have to be prepared to test that maximal output. So absolutely you want to test it. You're going to test it several times, in fact, in battery operation to make sure that the charging circuits and everything are working properly, and as we said, those impedance sensing circuits to make sure that they're working properly. There is still a requirement for a charge time test, which under the standards is required to be the 10th of 10 maximum energy discharges on battery.
Great. Another question for you. How many Impulse 7000 devices can be connected to one Answer software loaded in a PC?
Just one. Just one. The Answer software is automating your workflow in your inspection procedure. It's not a totally hands-off automation. It is an automation that helps you reduce sources of human error and can speed your testing, but it's not totally hands-off. So it's not designed to be, I can hook 8 defibrillators and run one test from Answer and it drives all. No, 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 no. One.
Okay, Dana, that is the end of the Q&A session. If you'd like to continue with the slides.
Absolutely. Well, if we didn't get to your questions or you feel that maybe you have more questions once you kind of let all this sink in. We will follow up with you after this webinar, but also don't forget to visit our Advantage Training Center that Jerry Zion here has put together for you for more information. There we have free training, quizzes, white paper, application notes, and videos for you to use. And we've provided with you the link to where you can access all of this information. And lastly, we frequently share helpful white papers, app notes, and videos on our social media outlets. So please feel free to follow us on Facebook or Twitter, perhaps LinkedIn, YouTube, or even Google+. And with that, I just want to thank you very much for joining us in today's webinar. We really enjoyed speaking with you and answering all of your questions.
Excellent. What a wonderful webinar. Thank you, Dana, for your time and the information you shared today. And again, TechNation would like to thank today's sponsor, Fluke Biomedical. Fluke Biomedical leads the world in design and manufacture of biomedical test and diagnostic imaging products. Visit flukebiomedical.com to learn more. Attendees, remember, to obtain your certificate of attendance, you must complete the post-webinar survey that will appear on your screen at the close of this webinar. Please visit imtechnation.com/webinars to register for our next webinar Wednesday, which will be on May 25th. As always, thank you for being a part of the TechNation community.